Lesson check 8.3. Before we get started, let's make sure that you've cleared the RAM on your calculator. So you want to do second plus 712. Every single time you clear your RAM, it's going to turn your diagnostics off. So we want to go to mode, down to where it says stat diagnostics, and you want to turn them on. So you want to go over to on, press enter, and now when we run our linear regression or anything we do on the calculator, it'll give us our R and our R squared value. So we really probably won't be asked to do that here, but just get in the habit of doing that just in case you need it for the exam. All right, so it says the following linear regression model can be used to predict ticket sales at a popular water park, where H equals dollars of ticket sales per hour and T equals temperature in degrees Fahrenheit, degrees F. So we have a lot of pieces of our equation. The variable that stands alone is your dependent variable. Typically in algebra, it was represented by y. The y-intercept, the starting point, the initial value for this one is negative 312.25. This is in dollars. So if I sell 0 tickets, then I'm out $312.25, okay? The slope is always attached to the independent variable. Again, in algebra, that's typically our x value. So this one is saying that for every extra, degree, as the temperature increases for each degree, then we can predict that our ticket sales are going to go up by $13.50. Just reminding you, the independent variable, the x, if you will, is always the one that's attached to the slope. So in this model, H, dollars of ticket sales per hour, H is the dependent variable, and T is the independent variable. Question number 2, what is true about the rate of change for this linear function? They want us to check all that apply. So you do need to remember that rate of change is our slope. So our slope value up here is $13.50. So as the temperature increases, for each degree, we can expect the ticket sales to go up by $13.50. Let's see what this says. The slope tells us a 1 degree increase in temperature is associated with an average increase of $13.50 in ticket sales per hour. I like that one. Our slope is in fact positive. It's plus $13.50. So yes, it is positive. The slope tells us that when it is 0 degrees, they predict a deficit of $312.25 in ticket sales. This is actually not the slope. This is what the y-intercept tells us. So that is not true. And then the slope is not, the slope is constant, sorry. It is staying $13.50. On a particular day at the park, the temperature was 85 degrees and the park made $815 in an hour. What is the residual value? Remember the acronym RAP, R-A-P. R stands for residual, A stands for actual, P stands for predicted. So to find the residual, you take the actual value for this problem is $850 and you subtract the predicted value. So what we do to find the predicted value is we go back to the equation they gave us up here at the top of H equals negative 312.25 plus 13.50 T. We're going to plug in 85 for that T because that is the temperature that day. And we're going to use this equation to find what we call H hat. It's going to have a little hat on top of it. This little hat is the symbol for predicted. So we're going to find H hat by plugging 85 in for temperature. And so when we calculate that, negative 312.25 plus 1350 times the 85, because that is the temperature we're plugging in for T, we do get $835.25. So according to the model that they gave us, it is predicted that they will make $835.25 in ticket sales for an 85 degree day. Okay, that's the predicted value, but they said they actually made 815. So to find the residual, which is what this question is asking us for, we need to subtract the actual 815 minus that predicted value. Okay, so we get a negative $20.25. We did not make as much money as we were predicted to make. So question number 4, were the amount of ticket sales anticipated is predicted, by the model for an 85-degree day, were they over or were they under for the prediction? $835.25 was higher than what they actually should have made, which is 815. So it was an over prediction. 835.25 was predicted. They actually only made 815. So they overestimated how much, or the model overestimated how much they were going to make. Okay. In preparation for buying their first car, a student wanted to determine if the age of a car could reliably predict the cost of the car. In the data they gathered, the average age of the cars they investigated was 10.2 years with a standard deviation of 2.1 years. Somehow my little lines there got thrown off. I'll go ahead and erase those out of our way. The average cost of the cars was $12,040.51 and with a standard deviation of $1,100. The correlation between the car prices and age was 0.682. Let's see if I scoot this over. No, it's not going to move for us at all. I don't want to mess it up too bad. All right, sorry that's covering it, but we're going to keep going. All right, so I'm just kind of pulling down all the different values that I'm going to need to solve the next few problems. On your formula sheet, you're going to have these formulas given to you for linear regression. Notice that we have our y hat, so our predicted y is equal to b naught plus b1x. Remember, the thing is right attached with the x, that is your slope. The other thing is the y-intercept. So our initial value is the b naught. That's our y-intercept. And then the b1 is our slope. So to find the slope, to find b1, you take r, which is our correlation, and you multiply it by the ratio, or that you're going to divide the standard deviation of y divided by the standard deviation of x. So correlation times standard deviation of y divided by standard deviation of x. To get the y-intercept, to get b naught, you're going to take the average of the y's minus that slope that you just found previously, and then multiply it by the average of the x's. So you really need to solve for the slope before you can solve for the y-intercept. So they've given us all these values, which is why I've kind of identified them here. We have our average of our x, standard deviation of the x, average of the y, standard deviation of the y, and then our correlation. So again, I wrote the formula sheet, formulas here so that we would have those to refer to. So in question number 5, it says, what would be the slope for the linear equation predicting cost from age of the car? They want us to round to 3 decimal places. So we're going to use the slope formula that says to take r times sy over sx. So our r value was given, the correlation was negative 0.682. Now I'm worried that it wasn't negative. Did I cover up the negative there? Let me erase that. Okay, it is negative. So negative 0.682. I was afraid my X bar was covering it up. Okay, so anyway, take that R value. The standard deviation of the y was 1100, and then the standard deviation of x was 2.1. So we're going to calculate that, do negative 0.682. I like to use a parenthesis and then fraction button. We have 1100 on the top, and then we have 2.1 on the bottom. So I'm typing it in, and that is where I got my slope to be negative 357.238. And it does say it wants 3 decimal places. You do have to include the negative or it will count it wrong. So make sure, don't lose your negative. Don't drop that. Okay, so we have that. Then they want to know what the y-intercept for the linear equation would be, predicting cost from age of car, rounded 3 decimal places. So we're going to go back and use our formula. B naught equals the average of the y's minus that slope we just found times the average of the x's. All right, so average of the y's was given to us as $12,040.51. And then the formula says minus. We want to put our slope that we just found, the B1. So we just found it to be negative $357 and I'm assuming dollars. Sorry, is this dollars? Negative 357.238. And then we're going to close that parenthesis, and then we're going to multiply it by x bar, which is 10.2, the average of the x's. Okay, so y-intercept for the cost, they want 3 decimal places. So 15,684 point, let's see, 3 decimals. So we're going to round, and that's going to be 338. Okay, 15,684.338. Don't put any commas, don't put any dollar signs, just put it as is. All right, how much of the variability in the prices can be explained by the age of the cars, leave in decimal form, and round to 3 decimals? So when you see the word variability, remember correlation is R, variability is R squared. So they gave us the R value earlier. It's called the correlation. They gave it to us to be negative 0.682. This is what I see students do, and it is wrong. Don't do this. They put this R value in with no parentheses and then put squared, and you have a negative answer, and then students go down here and give the negative answer, and it's wrong. Okay, if you want the calculator to square this correctly, we all know, and we've known this since early middle school or elementary even, that if you square a negative times a negative is a positive. But the only way the calculator is going to do that for you is if you put your value in parentheses. So negative 0.682 squared would be a positive 0.465. Number 8, based on the slope of the line, our slope of the line was negative 357.238, so we do have a negative slope. What general trend do we see between the age of cars and their prices? So if our slope is negative, then that means they have the two variables have an inverse relationship. As one goes up, the other one goes down. So your two options are going to be that the age of the car goes up, the price goes down, or as the age of the car goes down, so it's newer, the price goes up. So the newer a car, the less it costs. That is wrong. A 10-year-old car should cost more than an 8-year-old car. That's wrong. The older a car, the less it costs is correct. Okay, the last one is kind of a distractor. It might be correct, but it's not what we're seeing by this model that we found. So it says cars that are more than 25 years old are considered classics and should cost more. So this is just basically describing if we had some classic cars that were worth a lot of money in our scatter plot, they may be extreme values. They may be outliers because they're not going to follow the trend of the equation that we have of the majority of vehicles. As soon as you drive it off the lot, remember it drops in price. So the older it gets, the lower the price. Okay, so what is a residual? A residual, every time you see that word residual, I want you to think wrap. RAP stands for actual minus predicted, and this little hat means predicted. So this is the actual y value minus the predicted y value. That absolutely is true, but it does say select all that apply. Is it the vertical distance between a data point and a scatter plot and the line of best fit? Yes, it is. It is not the horizontal distance. It is the vertical distance between each point and that line of best fit. The difference you get when you subtract a data point from the next closest data point, that is not true. It is how far each point is away from the line, not from each other. And let's see if I made 100 on this, if I made any mistakes. I did get a 10 out of 10. So if you followed along with me, you should have 100 on lesson check 8.3. I may go in before you guys start this and fix that typo just because it's going to annoy me a little bit. So forgive me in the video that the word there is wrong, because y'all won't, it'll look correct for y'all. But that's lesson 8.3. Now you guys are ready to do homework 8.3.